Today we are covering linear system of equations, whereby we shall be able to look at one way of solving a system of equations. Still remember we are still under matrices. So basically we shall be solving using matrices. There are two methods basically that we shall be able to cover. One is called the inverse of a matrix method. The other one is called the Cramer's rule. So today I just want us to look at the inverse of a matrix because it requires a lot. Because what we learned last week on cofactors, again we have to repeat all that again. I don't want to assume. So the inverse of a matrix method of solving a system of equations. One is inverse. So you can be able to start with a system of two equations. Then we build basically from there. So if we have two equations whereby a1 x plus let's say b2y is equals to, let's say, c1, and a2x plus, it's supposed to be b1, and b2y is equals to c2. Let's say you have a system of two equations. Our first thing that we need to do is to form a matrix, basically a matrix of equations for this one. So we shall take the coefficients, which are a1, b1, a2, and b2. And then whatever we are solving for x and y. And then our solution, we shall represent it in form of a column, like that. A1, B1, so we form a matrix of equations, basically taking just the coefficients and taking now the x and the y. Now, let me call the whole of this one, let me call the whole of this one A, and the whole of this one, I call it capital X, and the solution here, I can be able to call it capital Y, like that, the solution. So I'm just on the theory bit again. So we are having AX is equals to what? To Y. So I want to solve basically for X. Remember, for the X stands for X and Y. So I want to solve for X. So in matrices, what we don't do, we don't divide by A both sides. In matrices, there's no division. So what we do, we multiply by the inverse. So we multiply by the inverse on the left hand side. On the left hand side of this one with the inverse, and again we multiply here the left hand side with the inverse. So that's how we do it. We multiply by the left hand of the inverse and the left hand side with the inverse. Now A inverse, remember in the introduction we had done A inverse times A, this one here, we are getting this one as the what? The identity matrix. This one was the identity matrix. So this side we shall get the identity matrix times X, which we shall be able to get A inverse times Y. Now, after getting that, the identity matrix times any matrix. So let me go back to what we had. So we had the, remember our I is 1, 0, 0, 1. Our X we have said is XY. And then our A was A1, B1, C1, sorry, A2, B2. Then we shall get the inverse of that one. And then our y was given by C1, C2. If you multiply the identity matrix 1, 0, 0, 1 by any matrix, we shall still get xy this side. We shall be given by the inverse of A, B1, A2, B2, and then this one is the inverse, and then C1, C2. So our main task basically is to get basically the inverse. You don't have to do all that. So our main task, what are we supposed to do? We just take the coefficients basically, get the inverse, and then multiply that one with basically the solution on the right hand side. So that's what we shall be doing to be able to come and obtain the value of x and y. So let me do an example to demonstrate this. I'll just do an example because we covered it in basic maths. I don't think it has a big of a problem. So example, we solve this one. Number one, we have 2x plus y is equals to 4. Now negative 3x plus 4y is equals to 5. Like that, we solve this one. So you can be able to see the system of equations. So first of all, we shall be able to form a matrix of equation. So in matrix form, we shall just take the coefficients 2, negative 3, and then 1 and what? 4. And then the x and the y is equals to 4, 5. So you form a matrix of equations. Basically, you can be able to see that the x, they have to be on the same column. So x and x have to be in the same column. Y and y have to be the same column. A column you move from up going downwards. That is the column. So our main task now, I can be able to call this one A for the easier method. So at least you can be able to see what I'm doing. So my main task is to be able to come and get the inverse of A. So A is given by 2, 1, negative 3, 4. But for me to be able to come and get the inverse, I need the determinant. This one signifies determinant. We have done this one before. So we'll be given 2 times 4 minus negative 3 times 1. If I do this one, I'm getting that is 8. 8 plus 3, I'm getting 11. Because a negative times a negative is what? Is positive. So that is the determinant. Now, you remember the inverse will be given by the reciprocal of the determinant, 1 over 11. Then what I need to do, I need to interchange. I need to interchange the leading diagonal. So I'll interchange this diagonal here. This one we did it last week. So I'll interchange this one, the one in yellow here. And then I'll multiply the one in what, pink here, the negative one, the 1 and negative 3, I'll multiply with negative 1. So let me interchange the leading diagonal. So I'll have 4 and 2. And then the other one I multiply with a negative, negative 1 and 3. Multiply negative 3 by a negative 1, we'll get 3. So that is basically the inverse of that. So I go back up again. So I'm solving now. So from the theory that we have done, what we need to do is to take our xy, multiply the inverse and the solution. The solution was 4, 5. The solution was 4, 5. So our xy will be given by basically this one, the inverse. If you want to multiply with 11 throughout, you can be able to multiply, sorry, 1 over 11. But for me, I love to wait. I love just wait. I'll divide later. Then 4, 5. Our solution was 4, 5. So remember how we are multiplying matrices. We are multiplying row, column, row, column. People who have forgotten. So I remain here with 1 over 11 xy. I multiply 4 times 4 plus negative 1 times 5. And I'll take 3 times 4 plus. So yeah, that's how I'm doing it. And then plus 2 times 5. So 16 minus 5. 16 minus 5, I'm getting as 16 minus 5, that is 11. And then what is 12 plus 10? I'm getting 22. So here I have x and y. So what I need to do now is to divide by 1 over 11. So x over y, xy, sorry, will be given by 11 all over 11, and then 22 all over 11. And the final answer I should be getting is 1 and 2. So it means that our x here is 1 and our y here is what? Is 2. Basically for that one. So the most important thing for you to note, we are getting just the inverse. After getting the inverse, then we multiply by the solution on the right hand side. But the inverse has to come before the solution. So that is basically for a 2 by 2, and that is a bit easy. We have already covered this one. So let me go to what my main interest is, solving for a 3 by 3 equation. 3 by 3 equation. equation. So this is the equation that I have. So we shall still use the same principle. X plus y plus z is equals to 4. 2x minus y plus 2z is equals to 5. Negative x plus 2y plus 3z is equals to 3. So that's the system that I have of equations. So what I need to do first of all is to form a matrix of equation. So I'll just take the coefficients again. This one we have 3 equations. So I'll take the coefficient of the first equation of x, that is 1, and then I get 2, then negative 1, 1, negative 1, and 2, 1, 2, and 3. Then I have 3 unknowns, x, y, and z. Then I'll have 4, 5, 3. 4, 5, and 3. So from there, what I need to do, I can be able to call this one A. So we shall still follow the same format. We need to get the inverse of A. After we get the inverse of A, then we shall be able to come and multiply. So, but before we get the inverse of A, we need the determinant of A. Determinant of A. Determinant will be given, we take the signs, remember the signs, the determinant. So let me put the signs, always remember that. We have this one is positive, negative, and positive. So the first one I have 1, and then you block the leading. So the leading will be negative 1 times 3. I get negative 3 minus, and then the other diagonal will be 4 minus 4. Then you will have a negative 1. When you block again, you multiply 2 times 3, that is 6. And then 2 times negative 1, you get minus 2. And then plus 1. Again, when you block, you'll get 4. Negative 1 times negative 1, that is just 1. So when you do this one with your calc, let us see what you're getting. The first one is negative 7. If I'm doing a mistake, you'll be able to tell me. Negative 7 minus minus 6 minus 8, and then plus 4. I'm getting negative 11, if I'm not wrong. Negative 11, negative 7 minus 8. No. Plus 3. I'm getting negative 12. I think I've done a mistake there. It's supposed to be negative 12. Confirm the answer. Negative 12. When you do all that, I'm getting negative 12. I'm hoping that is the correct. So if I make any mistake, you can interrupt. So after getting the determinant, we need now to get the inverse. So we go now basically to the cofactors. So I'll continue now with the signs. This one is negative. This one is positive, negative, positive, negative, positive. So last week we did the cofactors. So we shall take each and every element and then get the cofactors. After getting the cofactors, then we shall be able to transpose. And basically we shall be able to get the inverse. So the first one is we shall take the cofactor of 1. The cofactor of 1. The sign there is positive. So let me see what I have for the cofactor of 1. For the cofactor 1, I have negative 1, 2, 2, 3. Negative 1, 2, and then 2 and 3. Hope that is what I have. Negative 1, 2, yes, 2 and 3. That is the cofactor of 1. So this one, when I do it, this one, the leading minus, and so I'll have negative 3 minus 4. So I'll have negative 7. Negative 7. So I go for the next cofactor. The cofactor of again another one. We have another one. We have another one. Here the sign is negative. So the cofactor, basically you block the column and the row where the one is in the middle. So you remain with the 2 2 negative 1 3. 2 2 negative 1 3. So when you do inside, you'll get what? 2 times 3, that is 6. 6 minus 2, you get 8. But because the sign is negative, we shall get negative 8. It is the cofactor of 1. There's another cofactor of 1 still, but the sign is positive. So the one basically on the extreme left. So that one again, when you block the row and the column, you remain with 2 negative 1 and then negative 1 2. So 2 2 negative 1 negative 1. So when you do this one 2, that is 4. 4 minus 1, you get 3, and the sign is positive, so it shall remain as 3. Then we go to the cofactor of 2. Cofactor of 2. The sign there is negative. So again, I'll block. You block. For the 2, when you block, you remain with, you block the whole of that row in the middle, and then the first column. So when you block, you remain with 1 1 2 3. 1 1 2 3. 1 1 2 3. When you do this one again, that is 3. 3 minus 2, that is 1, but the sign is negative, so you remain with negative 1. So we go back again to the element in the middle of the pack, that is negative 1. The sign is positive. Again, I'll block. So you block the row in the row in the middle and the row and the column in the middle. When you block, you remain with the 1 1 negative 1 3. 1 1 negative 1 3. 1 1 negative 1 3. The sign is positive, so when you do this one, you get I'm getting that is 3 minus minus, so it will be positive 4. Then you go to the element 2. There's another element 2. The sign here is negative. Then when you block that row, you remain with what? You remain with the row and the column. You remain with 1 1 negative 1 2. 1 1 negative 1 2. That just confirm. When you block, yes, we are at the 2. The element basically in the middle and the extreme left. 1 1 negative 1 2. When you do again this one, the cofactor for this one, that is 2 minus minus. So you'll get what? 3. But there's a negative sign, so you remain with negative 3. Continue like that. We go to the next element. It's a bit tedious, but you have to do all that. Negative 1. The sign is positive. Negative 1. So I am on negative 1, basically on the last row. So when you block, you remain with 1 1 negative 1 2. 1 1 negative 1 2. Again, when you do this one, the cofactor, you are getting 2, so you'll get a 3 because the sign is positive. Then you go to this other one, in the middle, the 2 here, the 2 here. When you block the whole of this column and the whole of this, you remain with 1 1 2 2. 1 1 2 2. 1 1 2 2. I think the sign is negative. This one is for which element? Let me check. Wow, that is for element 2. Element 2. When you do this one, 1 times 1, and then you subtract, you'll just get a 0. Then I'm on the last one now, 3. Element 3. The sign is positive. Then when you block the final row and the last column, so you remain with 1, 1, 2, negative 1, 2, negative 1. Let me confirm. 1, 1, 2, negative 1. That's correct. So when you do this one, the sign is positive. That is negative 1 minus 2. That is negative 3 times a positive is still negative 3. Both those are all correct. Negative 1 times 2, yes, negative 3. So let me form the matrix of cofactors here to see. So let's just input all the values. So the first value that we got. So I'm moving from left to right. Negative
Excuse me.
7. Yes.
You see the matrix with 4.
Let me pause. Because these are just numbers and we are humans, we can easily make that mistake. So let me go back and see now. So I was moving from left to right. So the first one is negative 7, negative 8, 3. Negative 7, negative 8, 3. And the first one. Then we do the other one is negative 1, 4, negative 3. Negative 1, 4, negative 3. And then 3, 0, negative 3. 3, 0, negative 3. So we get the transpose of this matrix, CT. Let's transpose this matrix. How do we transpose a matrix? We interchange the row and the column. So this one here is a row, it will become my column. So I'll have 7, negative 8, and 3. Then I'll have negative 1, 4, and negative 3. And then 3, 0, and negative 3. Basically, the elements in the middle and in the leading diagonal, this one here, they are not affected. They still remain in the same position. They always remain in the same position. So let's get our inverse. Our A inverse was given by one of our determinant, what was negative 12, and basically the transpose matrix. That is our inverse now. Always remember the determinant. 3, negative 3. What was it? No, there's somewhere. Oh, so it is still okay. I've transposed. Okay, so 3, negative 3, like that. That's what I have for the inverse. Always the reciprocal of the determinant has to be in front. Now we go back to the basics, what we had done before. So what we need to do is to get the value of x, y, and z, we need to take our solution, which is 453, and multiply with the inverse. So just take our x, y, and z. Is equals to, okay, let me just rub this one. Is equals to 1 all over negative 12. Again, I'll take my inverse, which is 7, negative 1, 3, negative 8, 4, 6, 3, negative 3, 3. And then I multiply with my solution. My solution was 4, 5, and 3. That was my solution on the right hand side. That's what we had done on the theory. So leave the determinant, 1 over the determinant alone. We must first of all multiply inside. So again, row column. So I'll have 7 times 4. You can be doing this one plus negative 1 times 5. Yes.
Okay, I have a question. On our third row there.
So we shall have negative 7. So row column, negative 7 times 4 plus negative 1 times 5. and then plus 3 times 3. The one we shall have 8 times 5. Kindly mute. Can hear your brother talking. And then plus 0 times 5. The one is 3 times 4 plus negative 3 times 5, then plus negative 3 times 3. Has anyone done any of those ones? Let me confirm. The first one. Oh, so no one has done. So let me just do it. What we have. I'm getting one of.
Sir,
Yes.
see the second row.
Let me mute first of all. So in the first row is negative 28 minus 5 plus 9. I'm getting negative 24. Confirm? The first one I'm getting negative 24. That is negative 24. The second one, that is negative 32 plus 20. I'm getting negative 12. The other one I'm getting 12 minus 15 minus 9. I'm getting negative 12. Have you confirmed that's what I'm getting? That's what I'm getting. So if you multiply by 1 over 12, the first one, negative 24 all over negative 12, you'll get that one as 2. This one you'll be able to get it as 1. This one you'll be able to get as 1. So your x is 2, your y is 1, and your z is 1. Those are the values that you are supposed to get. Remember, you are multiplying by 1 over negative 12. Each and every element that is here. So that's why I'm getting 2, 1, and 11. 2, 1, and 11. So I'll do the final question. That is number 2 now. Negative 3x minus y minus 2z is equals to negative 2x plus 2y plus 3z is equals to 7. 2x plus y plus z is equals to 1. I hope let me do this one without so many mistakes. I'll be able to jump some steps on the cofactors, which are just block and then we multiply. So this one we shall have the matrix equation will be negative 1, negative 2, 1, 2, 3, 2, 1, and 1. Then I'll have x, y, and z. Then negative 2, 7, and 1. So I'm able to call this one A. I get first of all the determinant. So don't forget about the signs quickly. This one we block and we multiply. The first one is a negative 3, the element. A positive times a negative is still a negative. So let me block. So when you block, you get 2 minus 3, you'll get negative 1. The other element is a minus and a minus. So minus, minus 1. And then when you block the column and the row, you'll get 1 times 1. 1 times 1, that is 2. Sorry, 1 times 1, that is 1. 1 minus 6, negative 5. The other element is positive, but we shall have a negative 2. Yes. 1 minus 4, negative 3. Is it okay? I'm doing it. I'm blocking and I'm multiplying. Like the first one, I've multiplied those two. 2 times 1 and 3 times 1. So I'm getting 2 minus 3. That is negative 1. The other one, I've multiplied the 1 times 1 and then 3 times 2. So I was getting negative 5. The other one is negative 2. Then 1 times 1, that is 1. 1 minus 2, you get negative 3. So if I input all this in a calculator, I always love not to assume. So I'll have 3. 3 minus 5 plus 6. Confirm if you're getting it as 4. That is the determinant is 4. The determinant is 4 for that one. 4. Okay, no one has done it. Okay. So let me continue now. Now I'll go to the cofactors quickly. And you've said for the cofactors, we shall just be able just to block and multiply. Block and multiply, so at least we move a bit faster. Let me see the recording. The recording is already that 1 minute. I want it to be around 40 minutes. So I'll start with the first element, which is which is negative 3. Negative 3. So the sign is positive. Let me block and see what I'm getting. So when I block the first one, I'm getting 2 times 2. That 2 times 1, that is 2. And then minus 3, I'm getting it as negative 1. And because the sign is positive, it just remains as negative 1. I go to the next element, which is negative 1. Here the sign is negative. When you block 1 times 1, that is 1. 1 minus 6, get negative 5. But because the sign is what? Negative, I'll get 5. I'll go to element negative 2. Negative 2. The sign is positive. When you block, you remain with 1 times 1, that is 1. 1 minus 4, you remain with negative 3. The sign is positive, so negative 3. We'll go to element 1. The sign is negative. When you block the first column and the row in the middle, you remain with negative 1 times 1, that is negative 1. They can just be doing it with a calc. Negative 1 times 1, and then minus negative 2, negative 2 times 1. I'm getting it as 1. I'm getting this one as 1, but the sign is negative, so I get negative 1. I go in the middle, the element 2 in the middle, the sign is positive. Again, when you block in the middle, you remain with negative 3 times 1, minus negative 2 times 2. I'm getting it as 1. The sign is positive, so it will remain as 1. So I go element 3. The sign is negative. When I do the last one, I'll have negative 3 times 1 minus negative 1 times 2. I'm getting this one as negative 1. The sign is negative, so it will remain as 1. You continue like that for each and every element. You go to element 2 again, the sign is positive. Again, block the leading, so I remain with the first column and the last row. You remain with the negative 1 times 3 minus negative 2 times 2. I'm getting that one as positive 1. Then the other element is 1. 1. The sign is negative. Then I think I have another one here. The sign is positive. So that one there, when you block the column in the middle and the last row, that is negative 3 times 3 minus negative 2 times 1. I'm getting a very big number, negative 7. Negative 7, and because the sign is positive, is negative, I'll get a 7. I mean the last one. The last one I'll get negative 3, that is easy. Negative 3 times 2 minus negative 1 times 1. I'm getting negative 5. The sign is positive, negative 5, so negative 5. The matrix of cofactors, I can easily make it. I start with the last three, that is 1, 7, negative 5. The first one, negative 1, negative 1, 5, negative 3. And I have here negative 1, 1, and 1. That is the matrix of cofactors. Then I transpose this one. I transpose this one, CT. I'll get negative 1, 5, negative 3, negative 1, 1, 1, 1, 7, negative 5. Let's go to the inverse now. The inverse was given by one of the determinant, which was coming to, let me go up, the determinant was coming to 4. Determinant was coming to 4. So 1 over 4 of the transpose, negative 1, negative 1, 1, 5, 1, 7, negative 3, 1, negative 5. And from there now, we just have to calculate the value of x, y, and z. You can just take this one, a quarter of negative 1, negative 1, 1, 5, 1, 7, negative 3, 1, negative 5. And then we multiply with our solution. I go up, our solution was given by negative 2, 7, 1. Negative 2, 7, 1. Negative 2, 7, and 1. Let me multiply row column. So this one will be given by x, y, and z. A quarter. So negative 2. So I'll have negative 1 times negative 2 plus negative 1 times 7 plus 1 times 1. Then 5 times negative 2, 1 times 7 plus 7 times 1. The one is negative 3 times negative 2 plus 1 times 7 plus negative 5 times 1. So the first one, if I do it, then confirm with a calculator, a quarter. The first one I'm getting, that is negative 1 times negative 2 minus 7 plus 1. I'm getting this one as negative 4. That one is negative 10 plus 7 plus 7. I'm getting this one as 4. And then positive 6 plus 7 minus 5. I'm getting this one as 8. So when you divide, basically, a quarter of negative 1 over 4, you'll get this one as negative 1. A quarter times 4, you'll get this one as 1. And then 8 times 4, you'll get this one as 2. This one, our x is negative 1, our y is 1, and our z is 2. So that's how we do it, basically, for the inverse of a matrix. It's a bit tedious, but hoping the next method it will be a bit better. So I've given you an exercise there to go and try. You attempt the exercise, and please make sure at least you get the correct answer. So I've given one question, because I know it is a bit tedious when you come to the cofactors. The other method that we shall be able to introduce grammar school is a bit easier. Very easy. We shall still do the same examples, but we do with grammars in the next class. So